So in this case, we have got a revision that we are going to look into from our Eastern Cape education. That is for our grade 10 mathematics as we are revising for the exams which are ahead of time. So it was a paper one, which was written 1 November 2024. So we are going to use that to try by all means to figure out how these questions can be given as. And also, we're gonna try by all means to look for paper two. So, guys, if you've got question papers that are linked to the previous revisions, you can also send those ones so that we can also look into that. So, without wasting our time, we're gonna quickly go through the questions. Remember your instructions. You make sure that you read each and every part of the instructions that you are given, every part that you're given, especially that our answers, they are supposed to be rounded off to 2 decimal places unless stated otherwise. All right. And your diagrams, they are not necessarily drawn to scale. All right. So let us see what we are given on question number one. There we are given the k expression, which is given as a fraction. All right. Where x is given as an element, -6, -2, 1, and 4. These are the values representing the x that we have got here. Choose the given from the given set of data that we have, the set of numbers, which is the data that we are given there, a value of x for which k will be one of these. All right. So we just have to substitute, guys, the given numbers and see the type of number that we're gonna have at the end. Are we going to have a rational, irrational, non-real, or an undefined for a certain value of what? Of x. All right, so let us take our k. Our k is given as the square root of x plus 5. So that's x plus 5, everything over x minus 1. So let us start with -6 for a value of x which is equal to what? For a value of x which is equal to -6. It follows that our k is going to be equal to the square root of, we substitute in place of our x, the -6. All right, so that is -6 plus 5, everything over what? X minus 1. Remember, our x is what? -6. So it was going to be -6 minus 1. So this is what you're going to have at the end. So simplifying this part, what are we going to have at the end? -6 plus 1, this part which is under the square root. If you were to simplify the part which is under the square root, we are going to obtain a -1 from there. That is, our k is equal to the square root of -1 over what? -6 minus 1 in the denominator. That was going to give us a -7. So if we are to consider this part, the square root of -1 in the numerator there, because guys, let's say there was maybe square root of 4 over -7. If we're going to obtain a whole number there, like square root of 4 is what? Is 2. So it's going to be 2 over -7, which is actually same as -2 over 7. We are obtaining a fraction, which is in the form of what? A over B, where a and b are what? Are integers. So meaning to say we have got a fraction which is what? A rational. But in this case, the number that is in the numerator there, the square root of -1, cannot be simplified. We cannot simplify this. All right. So if we take our calculator, square root of what? -1. So that is, it cannot be simplified. We cannot simplify such. It is what? Non-real. So whatever that we are going to, because this cannot be simplified. So even if we are to divide by -7, nothing is going to come out from this. It cannot be simplified. So meaning to say, for a value of x which is equal to -6, the resultant is non-real. So the non-real part on 1.3, 1.13 is a condition where x is what? This is a condition where x is equal to -6. All right, let's move on. So we're just going to do like that, guys, testing our values, each value. Now, when this x is what? -2. We're going to substitute in place of what? In place of x when it is a -2. So that was the square root of what? Our x -2. So that's -2 plus 5, everything over what? Our x is what? -2. So that's -2 -1. So simplifying this, we're going to obtain -2 plus 5, which is what? Which is 3. There we have got square root of 3 over what? -1, -2 minus 1, that's what? That's a -3. So we have got square root of 3 over -3. The square root of 3, like I explained before, if it was square root of 4, we're going to simplify that. But can we simplify the square root of 4? The square root of 3? We do not know the exact value. Yes, it can be simplified on our calculator, square root of 3, as we can see. But it's an endless decimal. It cannot be written as a fraction. We cannot have it as a fraction. It cannot be written in the form of a over b. Yes, it can be simplified on our calculator, but it's not in what? In exact form. It's not exact. So when it is not exact, an endless decimal, that one, it is what? An irrational number. So meaning to say, we have got an irrational there. So when x is equal to -2, we are going to have what? An irrational number. All right, we move on to another condition. Another condition of our x, which is what? Which is 1. So we're going to substitute our k is equal to what? When we've got 1. So that was going to be square root of 1 plus 5 over what? Our x, which is what? Which is 1. So that's 1 minus what? Minus 1 from this part. Simplifying this, we're going to have our k equal to what? We add 1 plus 5, which is 6. So it's square root of 6 over 1 minus 1. That's a 0 there. All right. So in any case, guys, in any case, whether it was going to be a whole number, it was going to be a decimal. In any case, being divided by 0 like this, guys, it means we can no longer simplify that. It is undefined. Any number that we're going to see 1 over 0, undefined. So k over 0, undefined. X over 0, undefined. Any number over 0, that is what? Undefined. We cannot simplify that one further on because of the denominator, which is what? Which is 0. So that one, for a condition where our x is what? Where our x is 1, the answer is what? Undefined. So for when x is equal to 4, you are going to do the same thing. Substitute in place of what? In place of x. So that was going to be 4 plus what? 4 plus 5. Everything over our x, which is what? Which is 4. So that's 4 minus 1, like this, all right? So that was going to give us 4 plus 5, that's 9, square root of 9 over 4 minus 1, which is 3. We do know this one, the square root of 9 is what? Is 3. So we've got 3 over 3, guys. As we can see, it's a fraction. Even if we simplify 1 over 1, that's a fraction. We've got managed to write it in the form of what? A over B, where A and B are integers. So therefore, we are talking about what? A rational number. So for a condition where our x is what? Is 4, as we substituted here, we have got what? A rational number. So this is a condition where our x is equal to what? To 4. So that is what we simply needed in that condition. It was just like substituting and see. what are you going to get at the end? So just be quick, guys, as you are working with your questions. 1.2, we are given, factorize the following expressions fully. 1.21, all right? So 1.21, we are given 3x squared minus 48. We are supposed to factorize this fully. All right, so let's consider what we are given. There are two terms, all right? So we've got two terms, first one and the second one. So in that case, they are separated by what? By the minus in this case here. They are separated by a certain sign. That is why we are saying there are two terms. This one separated by what? A minus, then another term. So when you are given two terms, guys, use the golden rule. Look for what? The highest common factor. Always look for the highest common factor. So we are going to look into the numbers 3 and 48, which is the highest value that we can factor out. That's a 3 there. All right, so you can factor out 3. X squared, we do not have x on what? On 48. So we cannot factor out anything about x because x is not common. Remember, a highest common factor must be what? Common throughout. It must be a common term, a common number. So 3 is common. We can factor out 3 is there in 48. If we divide 48 divide by what? By 3, we can see that we've got what? A whole number. That is 48. In 48, we have a 3. That is what it means. All right, so factoring out 3, we're going to divide 3x squared divide by 3. That is going to give us what? X squared. 3x squared over 3 like this. So that's going to cancel and give us what? X squared minus, you do the same thing, 48 divide by what? By 3, what you factored out. So as we saw previously, that was going to give us what? A 16. So we've got x squared minus 16. So ask yourself, am I done? Most of you guys, you just think to factorize is to put in bracket. No. It is not about that, putting in brackets. You just think, all right, if the question is saying factorize, I just have to put in brackets. So if I see brackets like this, I would think that I'm done if I have that concept in mind. Factorization is not about putting in brackets only, but it is also to make sure what is under the bracket or what is inside of the bracket is in its simplest form. There are no common terms, or we do not have a difference of two squares. So you're supposed to look for that. Here there is a difference of two squares. X squared is a perfect square. 16 is also a perfect square. So thus, from our difference of two squares, a squared minus b squared gives us what? A minus b into a plus b. 16 here can be written as 4 squared. So it's a difference of two squares. There is x, there is what? There is 4 raised to the power of 2. So those are the two numbers that we need. So it's 3 into x minus the square root of 16, which is what? Which is 4. Another bracket is going to add, so that's x plus 4. So it does not matter the order here. You started with the first, with the x plus 4 or the x minus 4. The order does not matter. You can start with anyone. All right. So as long as we've got these two brackets and what? A 3. It is fine. The order does not matter. All right. Let's consider 1.22. Again, factorize. So I talked about different ways, methods of factorizing such, where we have got a trinomial, and in that case, the coefficient of x squared is not a 1. Remember, we talked about the cheat method, so many ways. So as for you guys, I just want you guys to use any method that you understand, but at the end of the day, we're going to have what? Same answers, all right? Remember, from our cheat method, we said what we want is to make sure that the coefficient of x squared is 1, as we are used to that x squared plus 3x plus 2. If it is 1 like this, I just gonna need what? 2 brackets. I write x and x here. I look into these 2 and the 3. That condition is easier because of what? A 1. So that is how we're going to cheat this part so that it's going to give us a 1. So how do we remove it? We multiply it to the constant term. The 2 that we have, we multiply it to the constant term. So it's going to be x squared plus 3x minus 2 times 2, which is 4. So we have a 1 this time. We cheated the first part. It was not supposed to be like this, but we had to remove it, multiply to the other term. All right, anyways, we are back now to what we are used to. When the coefficient of x squared is 1, we are used to this. We're going to have 2 brackets. This is x and this is x. Focus on what? -4, which is our constant. What are the products or factors of what? -4. When you multiply, when you add these, you must obtain a +3. You are used to do that. Two numbers. You multiply these two numbers, you get -4. So -4, all right, products or factors of what? Of -4. There is -4 and 1, 4 and -1. There are so many, 2 and -2, -2 and 2, of which this one, guys, is just one and the same thing. All right. So anyways, these are the products. But of these products, we need a condition where we add these products now to obtain +3. Which condition is going to give us that? This is the 4 and the -1. If we add these two, they're going to give us what? A +3. 4 plus -1, that's what? 3. So we have 4 and a what? A -1. 4 and -1. Those are the two that we're going to put in our brackets. So if we leave it like this, it's wrong because we factorized something which was not our question. Remember, we had to cheat on the first part here. So what are we going to do? The 2 that we removed back then, we must bring it back. So we bring back the 2 wherever there is x. This is x, you put the 2 there. Where there is x, you put a 2 there. So these 2, you're going to put it back where there is what? Where there is x. All right, so let me do this. You put it here where there is x. You also put it here where there is x. So it is going to be 2x, 2x. That is what you do. Now, with this, you factor out any part which is common, any of the brackets, as long there's a common term. As long there is what? A highest common factor. The first bracket, there is 2, there is 4. 2 is common here, so you can factor that 2. All right, so we can factor out the 2 which is common, meaning to say we're going to have 2x divided by 2. That's what? That's x. 4 divided by 2. That's what? That's a 2. All right, the second bracket, nothing is common. So we're just going to rewrite as it is 2x minus 1. So the 2 that we factored out is not important. It is that play around number that we used before, that we used there, we used there. So in any case, whatever that you factor out won't be important. Your final answer will be these 2 brackets, all right? So this is a type of a question where someone can even factorize it by sight, by just looking into the question. You can even factorize this type of a question. So it is in your hands. At the end of the day, these are the 2 brackets that you're going to have. The order does not matter. Which one are you going to start with? All right, so I want you guys to use any other method that you learned in your class using these ones also from your YouTube videos. You're going to see that you're going to obtain the same answers if that is a valid working that you are using. All right, 1.23, we are given y minus xy there plus x minus 1. Remember, the concept is to what? Is to factorize. We are supposed to factorize. This time we are given 4 terms. 1, 2, 3, 4. Whenever we've got 4 terms like this, remember by what? By grouping. Factorization by what? By grouping. Grouping into 2 terms so that we can factor out what is common. So we can actually try according to what we are given on the first 2 terms. Let us try and see if we are to factor out here there is y there minus xy. Then here there is x minus 1, x minus 1. Look at the order there. If you just, like, guys, when you are dealing with factorization, by just looking into it, when you see that you're gonna factor out y, it's gonna be 1 minus x. Look where the x is and look here where the x is. X is starting here. Let us rewrite x on the second term so that we do not have confusion in terms of what we are doing. So this is what I'm trying to say. You can just rewrite this as y minus xy like this. Then, guys, rewriting does not affect the sign. We are just starting with the number, which is our constant, minus 1. Then we end with what? With the x. As it is, it was a plus. It is just rewriting to say the first one is just a constant, then the other part is x. So that when we factorize, like what we saw previously, to say y is common. So when I factor out this, I want you to see what's going to happen here. If we factor out this y, what are we going to have? Y divided by y, that's what? That's a 1. Minus xy divided by y is what? It's going to be x. So we have got 1 minus x, which is in the same order as what we are given to say we are starting with 1 and the other part is what? Is x. But we must factor out between these two terms that are common. We must factor out a term that will make the bracket that you're going to have here be the same as this one. We must have same brackets here. Same. They are supposed to be same brackets. So what are we supposed to factor out? So that the brackets that we are going to have here will be the same. Is it plus 1 or is it minus 1? You must be careful. If you factor out plus 1, it does not affect. It's going to remain as minus 1 plus x, which is different from this. Here, 1 is positive, not negative. X is negative, not positive. But if we factor out minus 1, this is what will happen. Minus 1 divided by minus 1, that's a positive 1. Positive x divided by negative is going to be negative x. So as we can see, 1 minus x is going to be obtained when we have factored what? Negative 1, which is exactly the same as this one. So the number that we are supposed to factor out there, it is supposed to be what? A minus 1. So be very careful on choosing the number there, because you'll be tempted just to say plus 1. No, you must consider to say that after factorizing, the brackets are supposed to be exactly the same. So minus 1 and minus 1, we say that's positive 1. X to minus, we say that's what? That's minus x. As we can see, the two brackets are exactly the same. So if we have got this condition, therefore, we are going to conclude that we factor out that common bracket, which is 1 minus x. When we factor it out, we are going to remain with y. Here, we are going to remain with what? Minus 1 in another bracket. So in this case, we have factorized fully. We have fully factorized, of which there are so many ways. But once you consider these two brackets, as long they are the same in whatever way that you're going to use, it's going to be fine. Same brackets. All right. So that is what we had on question 1.23, which was for 3 marks. All right. Okay. That is fair enough. All right. 1.31, we are given now. Determine the product of these two. All right. So there we can determine the product, just expansion of brackets there. So that's 1.31, where we are given 3p minus 2 and a bracket of what? 9p squared minus 6p plus what? Plus 4. So this is what we are given. Let us expand our brackets, guys, starting with the 3p. Remember, the terms in the first bracket must expand the second one. So there is 3p and there is what? A minus 2. So 3p, we start with 3p, it expands everything in the second bracket. So it's 3p times what? 9p squared. So that's going to be 3 times 9, which is what? 27. P times p squared is going to be to the exponent of 3. All right. 3p multiplies negative 6. 3 times negative 6, that's going to be what? Negative 18. So you're going to have negative 18 p squared. All right. P times p. 3p and this 4. That's 3 times 4, which is 12. So it's going to be 12p. Okay, we are done with 3p. We move on to the negative 2. The negative 2 multiplies the 9p squared. So that's negative 18, negative 18 p squared. All right. The negative 2 multiplies the negative 6p. Negative times negative, that's a positive. So 2 times 6, that's 12p. All right. Negative 2 multiplies the positive 4 here. So negative to positive, that's a negative. So it's going to be negative 8 there. All right. So this is what you're going to have. And from there, we can collect our like terms. That is going to be 27p to the exponent of 3. There is the part of p squared. Those are like terms raised to the same power. It is the p raised to the same power. So that's minus 18p squared minus 18p squared. So minus 18 minus 18 is going to give us what? Minus 36. So that's minus 36 p squared. They are also like terms. We have got the part of p, which is 12p here, and there is another 12p here. So we add 12 plus 12, that's going to be what? 24. All right, so that was going to be 24p. The minus 8 is just a constant on its own. So that is negative 8 at the end. All right. So this is what you're going to have, just like the previous case. You just have to collect your like terms, then simplify further. We have had questions like this previously. We dealt with such questions. It is not the first time. So just revise, guys, as many questions as you can. 1.32, simplify fully this expression or term that we are given combined to give us a single fraction. 10 to the exponent of 2x plus 3 times 4 to the exponent of 1 minus x, everything over 25 to the exponent of what? 2 plus x. So this is what you're given, and the question is you are supposed to simplify this fully. All right. So whenever you are dealing with simplification, it is very, very important that you consider how the question is given. There is a 10, there is a 4, there is a 25. These numbers, they just have something in common. There is 2, 5 there, something like that. Whenever you've got this condition, it's a product, try to rewrite the number as a product of its prime factors so that we can see all the numbers in their simplest form. So the best as a product of its what? Prime factors. So let's start with 10. 2 into 10, that's 5. 5 into 5, that's 1. So 10 is same as what? 2 times 5. In its simplest form, as a product of its prime factors, 2 times 5 to the exponent everything. We expanded the 10. So everything, which is 2 times 5, is raised to the exponent of what? 2x plus 3. Multiply 2. The 4 as a product of its prime factors, guys, that's 2, 2, 2, 1. So that's 2 times 2, which is what? 2 squared. So we have got 2 squared to the exponent of 1 minus x. Everything that we are given here is over 25, the same. 5 into 25, that's 5. 5 into 5, that's 1. So it's simply what? 5 times 5, which is what? 5 squared to the exponent of what? 2 plus x, as it is given there. Okay, so this is what we have got now. This is what we have. They are in simplest form, these numbers. Prime numbers, always. Those are the simplest numbers that we can ever have in mathematics, prime numbers, as they are divisible by 1 and itself. So always target that, prime numbers. Now that we have got these, there are laws now to be used. You look for the laws. Let's start with the first one. A single bracket raised to a certain power. What is the condition that we are given there? How can we simplify such? Where we are given a single bracket raised to a certain power. Remember, a b raised to the exponent of n is same as a to the exponent of n times b to the exponent of n. Everything will be raised to the given exponent. So it is the same thing as what we are given on our question. It is the same thing. We have 2 times 5, just like a times b. So each term or each number that you are given inside of the bracket must be raised to the exponent of 2x plus 3. So that's 2 raised to what? To that exponent. 2 to the exponent of 2x plus 3 times, there is a 5 also raised to that exponent. So that's 5 to the exponent of 2x plus 3. We have used a law. What is happening here? There is an exponent to another exponent. Is there a law which tells us that x can be multiplied to the exponent of a and also to another exponent b? Yes. What is that we do? We multiply the exponents x to the exponent of ab. There is a law there. You just combine the exponents by multiplying. So you just multiply. 2 multiplies everything in that bracket. So that's 2. It's going to be times 2 to the exponent of 2 times 1, which is 2. 2 times negative 2, which is what? Negative x, which is negative 2x. All right? Everything over what? The same concept as we can see. Exponent to exponent, same law. So that is 2 is going to multiply everything in the denominator there. So that's 2 times 2, which is 4. And we have got 2 times x, which is what? Which is 2x. So it's 5 to the exponent of 4 plus 2x. This is where we are. Laws of exponents. Now that we are at this stage, we can see that there are laws to be used or applied. Same base of 2 under a multiplication, as you can see in the numerator. Same base of 2. There is another base of 2 under a product. How do we simplify? When we are given same bases, x raised to the exponent of a multiplying x to the exponent of b, we add the exponents a plus b. We add exponents a plus b. So meaning to say, we are going to add the base of 2 that we are given there, 2 to the exponent of what? The first exponent, 2x plus 3. All right, 2x plus 3. Then we add the second one. So addition, there is no need for us to open brackets, guys, when you're dealing with what? When we are dealing with addition, just combine as it is. So it's plus 2 minus 2x, all right? That's for the base of 2. For the base of 5, is it a multiplication here? No, it's a division. 1 is in the numerator, 1 is in the denominator. That's a division. What's the law there? Same basis, but there is a division. X to the exponent of a over x to the exponent of b. You subtract the exponents. Subtract. So that condition here, it was going to be times the 5, which we are given as our same base. But we must subtract the exponents. We're going to take this one, which is in the numerator, this one in the numerator, 2x plus what? Plus 3. Then we subtract the other one, this one, in the denominator, a minus b. A in the numerator, b in the what? In the denominator. So what are we subtracting? 4 plus 2x, an expression, subtraction. We must have a bracket because we know that negative affects everything. It's different from a positive where I said ignore the bracket. Yes, we're supposed to have a bracket here, but addition does not affect, guys, all right? So you can just ignore that one for addition. But if you do not understand, then put the brackets, right? So this is where we are. We can simplify each. All right. So what are we going to have? 2 to the exponent of what? They are like terms. Yes, we have got like terms here. 2x and minus 2x. So 2 minus 2, that's a 0. Those two are going to cancel. All right. We remain with what? 3 and 2. So 3 plus 2, that's what? That's 5. So 2 to the exponent of 5 times. Here you're going to expand the bracket. All right, so it was going to definitely give us 5 to the exponent of 2x plus 3. We expand by negative, so that's negative 4. Negative times 2, negative 2x. So as we can see, we've got like terms again here, 2x minus 2x. So you're going to remain with 5 to the exponent of 3 minus 4. 3 minus 4 is what? Is minus 1. So this is where we are. Which concept, which law can be used? There is a number raised to the exponent of a negative. A law has to be used there. Remember, x to the exponent of minus n is 1 over x to the exponent of n. So we can simplify this as 2 to the exponent of 5. There is nothing about, there is no other term with a 2. We do not have any other 2 there. We do not have that. So just simplify. What is 2 to the exponent of 5? You can multiply 2 times 2 5 times. That is going to give us what? 32 times 5 to the exponent of negative 1. Using this law, it is going to be 1 over what? 1 over 5 to the exponent of 1, which is same as what? Which is same as 1 over 5. So there it is just a multiplication, guys. You are multiplying 32 over 1. 32 can be written as what? As 32 over 1. So we know that for a product, you're going to multiply the numerators together, the denominators together. So meaning to say at the end of the day, we were going to have our answer as what? 32 times 1, that's 32. 1 times 5, that is what? That is 5 there. All right, so that is it. So we're going to have 32 over 5 at the end of the day. So this is how these questions actually can be given, as we just have to be careful in terms of the presentation. That is how you can have your questions. All right, so that was it on this one, as we can see. All right, as we can see, that is what we had. Let us see another question. If we are to consider the other part of the question, this time we are given, all right, let's check, that's simplify. All right, so there we are to simplify. Okay, so let us start by factorizing, guys, where it is possible, before we can simplify whatever that we have. The first one, all right, it was how many marks? This one, 4 marks. Okay, so that's a 4-mark question. Let me just try to increase. All right, so it was a 4-mark question, as we saw, guys. So the first one, I'm just gonna do it here. X cubed plus 2x plus 4. We can see that there are 3 terms, 1 2 3, but all of the terms, there is x. There's x here, there's x here, there's x. So x is common. We can factor out the highest common factor, which is x. So it was going to give us x cubed divided by x, which is x squared. 3x squared divided by x, which is 3x. 4x divided by x, which is what? Which is 4. All right. Everything over what? The denominator, which is x cubed minus 8, which must be factorized. How can we factorize this? All right, let's go back to this one. X cubed minus 8. Remember, from our difference of two cubes, when you're dealing with two cubes, a cubed minus b cubed is equal to a minus b into the bracket of a squared plus ab plus what? Plus b squared. So what we just need is to have a term raised to the exponent of 3 and another one. So already there is x to the exponent of 3 there. What about 8? 8 is the same as 2 to the exponent of 3. So by just noticing this, we can tell that there is our a and there is our b. So factorization can be done. As we can see, we are saying from this, we are going to have, if this is A, if this is B, we are going to have what? A minus B, which is x minus 2. A minus B, x minus what? Minus 2. Into what? A squared. So A squared, our A is what? Is x. So it's going to be x squared plus AB plus AB. Our A is x. Our B is what? Is 2. So x times 2 is what? Is the same as 2x. So it's plus there. Plus AB. So that's going to be 2x. Plus B squared. Our B is what? Is 2. So what is 2 squared? 2 squared is 4. So that's a plus 4 that we are given there. All right, where am I getting the 3 on the first one? There is supposed to be what? This is 2x squared. This is 2 there, isn't it? Let's correct this one. This is 2 here. 2x squared divided by x is 2, all right? I'm seeing there later on it's just rewriting in the wrong manner, but that is what? That is a 2 there instead of what? Instead of a 3. All right, so that is what we have got there. Then plus 2 into what? It's already in simplest form. There's nothing that we can do on this one. Then on this other section, there is 2 minus x. Guys, look how we are starting with other terms. Or we are starting with x. But then we are starting with what? An whole number, which we are starting with a constant. So can we rewrite 2 minus x starting with x? Yes, it can be done. It'll be minus x plus 2. It is the same. We haven't changed anything. A plus B is the same as what? B plus A. As long you are maintaining the sign as it is there. Minus x, minus x. Positive 2, positive 2. It's the same. But now we want to have it as a positive x, as we can see positive x, positive x. So how can we make this x to be positive? We factor out a negative. Negative to negative, that's a positive. 2 divided by negative, that's a negative. So wherever we are seeing the 2 minus x, we can rewrite it as minus into x minus 2. It is the same. Once you expand this bracket, you are going back there. So we haven't changed anything. The other part, it is 2 plus x. 2 plus x, it is the same as x plus 2. And already our x is positive. So we cannot change anything. We're just going to rewrite as it is x plus 2. There it was a negative. We must always work with x as a positive value. All right? So that we do not miss our simplification. This is where we are. This is where we are. Before we consider to say it's an addition where I'm supposed to look up about this lowest common denominator or the lowest common multiple, there were expressions there which were not in exact form. So you had to factorize so that you have got them in exact form. Once they are in exact form, therefore we can try to simplify them before adding. As a fraction here, this one as it is here, is there anything common that we can cancel between the numerator and the denominator? Between this only, it's not a product, this one where we look across. It's not, it's an addition. So you look on the fraction, on this fraction only as it is. Is there anything that we can cancel? That is what we do. So here there is x squared plus 2x plus 4, x squared plus 2x plus 4. They can cancel. So it was going to give us x over what? X minus 2. All right. So we are going to have x over x minus 2. All right, here we factored a minus, remember. So there are two signs which are outside of the brackets, a plus and a minus. They're outside of the brackets. So which one is going to dominate? Plus and minus, it's what? A minus. So at the end, we're going to have a minus here. Minus, all right? Then let us consider any bracket which it can be cancelled, x plus 2. There is x plus 2. So we're going to have or to remain with what? With 2 in the numerator and x minus 2 in the denominator. As we can see at this stage, guys, we can notice that there's something happening here, which is what? The denominators are the same. 3 over 7 minus 1 over 7. If the denominators are the same, we know that we just have to combine the numerators under that same denominator. So it is going to be 3 minus 1 over 7. It is the same thing. There is x minus 2. There is x minus 2. Same denominator combine under that denominator of x minus 2. What are we to combine? The terms that we are given in the numerators, we combine them as they are. So there is x minus, there is what? 2. So as we can see, guys, we are left with what? X minus 2 over x minus 2. These are exactly the same. They can cancel each other to give us what? A 1. So this whole fraction that we're given to add, to subtract, this and that, which started with addition, now it ended up with a subtraction. At the end, guys, it's going to give us a 1. Simplify. Know your factorization. Know your factorization. The basics from your grade 9 mathematics into your grade 10 mathematics now. Know all the basics. All right, let's consider another one, question 2. We were given on question 2 that is solve for x on 2.11 when we are given that h is equal to half g x squared. We are supposed to solve for x in terms of h and g. That is, just to solve in terms of those letters. Do not simplify. We do not have a condition where we are going to have an exact value. It will be written in terms of h and what and g. So what can we do? Let's start with a half that we are seeing half there. How can we get rid of that 1 over 2? We can multiply by 2. The inverse or the reciprocal of what? Of a half is 2. So half of 2, that was going to cancel. So we're going to have g x squared is equal to 2 times h, which is 2h. We can see that there is a g which is affecting x squared. Get rid of that. Get rid of that. So divide by what? By g. Divide by g, both sides. So that was going to cancel this one. So we have got x squared, which is equal to 2h over what? Over g. To find x, we need x. So it's x squared. Just like x squared is equal to 4, you introduce what? The square root. X is equal to plus or minus 2. So it's the same thing. We introduce what? The square root, both sides of our equation. So we are going to have x, which is equal to this one. Whatever that we're going to have here, we know that answer was going to be what? Plus or minus. So we can even indicate that the answer is going to be plus or minus the square root of what? Of 2h over g. So forgetting the plus or minus, all right, does not affect. It's still going to give you full marks there. But in terms of a proper simplification, let's not forget to put the plus or minus, because we are saying there are two possible values that we can have from the square root of a number. There are what? Two possible values. So that was it on this one. Let us move on to 2.12, which is again to solve for x, and that's a quadratic equation that we are given there. X squared minus 10x plus what? Plus 24 is equal to 0. Remember your factorization method. When the coefficient of x squared is 1, there's a direct factorization. So we are supposed to factorize our left-hand side in that case, all right? So that's it. We're going to put x here and x, so that x times x is going to give us what? X squared. Remember to focus with the constant, positive 24. What are the factors of 24? Which adds up to negative 10. So that's 24. There are so many factors, guys, for 24. The 24 on its own and 1, negative 24 and negative 1, 6 and 4, negative 6 and negative 4. There are so many. We can also consider there is 8 and what? 8 and 3, minus 8 and minus 3. So many. But of all these factors, which condition where we add, we're going to get what? A negative 10. That's negative 6 and negative 4. If we add these two, we are going to get a negative 10. So these are the two numbers that we need, negative 6 and negative 4. All right, remember it's an equation, so equate to the 0 that we are given there. So that's equal to 0. We are back, guys, to the 0 concept. Two brackets multiplied together to give us a 0. It means either one of these brackets is equal to 0. Either x minus 6 is equal to 0 or x minus 4 is equal to 0. So what is the value of x? The minus 6 to the other side is going to be positive. The minus 4 to the other side is also going to be positive. So x is equal to 6 or what? Or 4. Just like that. Just like that. So let us consider another one, an exponential equation on 2.13. We had, or we are given an exponential equation, 2.13, 1 over 2 to the exponent of 3x minus 1 is equal to 128. All right. 1 over 2, remember x to the exponent of negative n is 1 over x to the exponent of n. So this can be rewritten as what? 2 to the exponent of negative 1 to the exponent of 3x minus 1. 128 in the base of 2 is what? 128 is equal to what? Then shift fact. That's 2 to the exponent of what? Of 7. Remember, when the bases are the same, we know that the exponents will automatically be what? Be the same. So it means that minus 1 into the bracket of 3x minus 1 is equal to 7. That's a linear equation that we have now. So you can solve for x, expand by negative or divide by negative 1. It is in your hands, all right? You can choose to expand by negative 1. That's negative 3x. Negative 1 times this, that's positive 1, which is equal to 7. Minus 3x is equal to what? We subtract 1 both sides of our equation. So 7 minus 1 is what? Is 6. So that's it. If minus 3x is equal to 6, therefore, what is the value of x? Divided by negative 3. X is equal to this one, negative 2 at the end of the day. All right, so that is how these questions can actually be given, as you just need to know your basics of your equations and so on. All right, let's check our question 2.2, where we have got a simultaneous, sorry, that's 2.3 is simultaneous 2.2, where we have got our inequalities here. We need the 2.2. So 2.2, we have got minus 5, all right? So that is 3x minus 2. 3x minus 2 is greater than or equal to minus 5, but less than what? Less than 7, for x is an element of all the real terms. Solve for x on 2.21. All right, so you can solve this one direct. Let's get rid of the negative 2 here. We take it to the other side, it's going to be positive. We take it to this side, it's going to be what? Positive 2. So that's minus 5 plus 2, which is what? Minus 3. Then we have got 3x there is less than 7 plus 2, which is what? Which is 9. There is 3, which is affecting x. How is this affecting x? As a product, so how can we get rid of that product? Divide by 3, each and every term. So that's it, 3 into negative 3, that's what? -1. Then 3 and 3 gonna cancel. We've got x. 9 divided by 3, which is what? Which is 3. So that is it. That is it. X is greater than or equal to -1, but less than what? Less than 3. So that is what we have. And the further question was 2. Hence, represent your answer to question 2.21 here on a number line. So on a number line, we just need the x values, guys. All right. So that's 2.22. Our x values, which are important, are the ones that we can see here, -1 and what? 3. So -1, let's say it's here. We're going to have a 0, then a 3 somewhere there on the positive. So where x is greater than or equal to -1, remember, greater than or equal to, less than or equal to, you shade that circle. So you're going to shade. For a less than at 3, you just draw a circle which is not shaded. Then you can join these two. You are done. So that is it. These are the x values that we are talking about. All right. So that's it from -1, but less than what? But less than 3. With this one, you know that you'll be done. All right. So these questions, guys, are just like more of a repetition, more of a repetition. Then 2.3, it was the one of the simultaneous equations. All right, there are two equations already given. I'm just going to take equation 1, make y the subject of the formula. I'm just going to use substitution method here, guys. 2.3, I'm going to use substitution method. All right, from equation 1, equation 2, I'm going to make y the subject on equation 1. That is, take y to the other side. It's going to be positive. Then take the 10 to the other side. So it's going to be -2x minus 10. So that's another equation which I can call equation 3, not equation 2. This is now equation 3, where y is the subject of the formula. So with that y as the subject of the formula, I can substitute it in what? In equation 3. So substitute, that's equation 3 into equation 2. All right, in place of y there. So it's going to be what? 3x minus 4y in place of y minus 4. In place of y, you are going to put what is equivalent to y there, which is what? -2x minus 10. So that is it. And it is equal to what? It is equal to -4. So let's solve for x. As we can see, we've got a linear equation with only x. So we can solve for x, expand the brackets. As we can see, there is a -4, which is to expand our brackets here, this one. The number that is on the bracket is what? -4. So you expand by that. -4 times -2x, that's positive. Negative to negative, that's positive 8x. -4 times -10, that's a positive 40. All right, so it's going to be positive 40, which is equal to -4. We can collect the like terms. As we can see that we have got the x there, 3x and 8x. So 3 plus 8 is going to give us what? 11x. So that's 11x plus 40, which is equal to -4. So taking the 40 to the other side, or simply subtract 40 as we are adding. So simply subtract 40 both sides. That's 11x is equal to -4 minus 40 is what? -44. So we can find x by dividing by 11, which is going to give us what? -4 by 11 by 11. So our x is going to be negative what? -4. With the value of x that we have here, we can now substitute it back in any of these equations, equation 1, equation 2, equation 3. So we can see that equation 3 is the best, as y is the subject, since we need to calculate the value of y there. From our equation 3, y is equal to what? -2x minus 10. So it's -2 into x. What is the value of x? x is minus 4. So that is what we are going to have, minus what? Minus 10. So that is it. We can find the value of y from there. Minus 2 times minus 4, that's what? Positive 8. Minus 10, y is equal to 8. Minus 10, which is what? Negative 2. So those are the two possible values that we're going to have. X is minus 4 and y is equal to what? Y is equal to minus 2. So questions can actually be given in that format. Simultaneous equations, you just need to figure out how to solve. You can use any method, any applicable method in your syllabus. Is it elimination? Is it substitution? That can be your choice. All right. Calculate or write down the value of p from what we are given as a linear number pattern. From our linear number pattern, what will be the value of p? So we can see that these numbers, they are actually decreasing. 37, 33, 29. How are they decreasing? How are they decreasing? 33 minus 37. Remember, term 1, term 2, term 3. The distance, the difference, which is our constant difference, supposed to be what? T2 minus T1. So 33 minus 37 was going to give us negative 4. The same thing that we are seeing, 29 minus this, that's a negative 4. So there's a difference of what? Negative 4 in between. So to get the value of P, we're simply going to add the minus 4 on what? On 29. So it's 29 plus minus 4, which was going to give us what? The P, which is 29 minus 4, which is what? 25. So actually P is equal to 25. There's a difference of 4, minus 4, minus 4, minus 4, minus 4, minus 4, like that. Okay, so it was just a direct question, this one. Then determine the expression of Tn. That is the general term of the number pattern. So from our grade 10 mathematics, we can actually work with different ways of finding this Tn. Let's go back to our grade 9 mathematics, grade 8 mathematics. How were we determining the Tn of what? A linear pattern. Remember, we talked about Tn equal to dn plus what? Plus c, where d is the constant difference, which we can already see we have it on our expression. The number pattern that we're given, we already determined that, which is what? Negative 4. So we've got negative 4n plus what? Plus c. That's it. So to find, you see, you must substitute any corresponding term. Is it term 1, term 2, term 3? It's a choice. So let us use T1. T1 is equal to what? 37. So meaning to say when n is equal to 1, in place of n, put a 1 there. So that is what it means. So 37 is equal to minus 4. In place of n, we're going to put a 1. Then we find our C. So that was it. Negative 4 times 1, that's a negative 4. Then we take it to the other side. It was going to be positive 37 plus 4, which is 41, all right? So 41 is equal to C. Therefore, we can rewrite our Tn as what? Minus 4n plus C, which is minus 4n plus our C is what? 41. Just like that. We had this type from our grade 8 mathematics, grade 9 mathematics. So if we are to consider another way, we can see that, all right? So let us see if we're going to have the same answer on this one. Remember, I also talked about this. I think I explained it, guys, to you. If I did not, therefore, just understand it from here. Tn can be obtained from this formula, a plus n minus 1 times d. It's another formula that we can use to find our Tn, where a represents the first term, our T1. In this case, our T1 is what? Is 37. And D is our constant difference, which we calculated before from T2 minus T1, which we got what? -4. And N is the number of terms. So already this must be in terms of N, so there is no substitute for N there. We substitute A and D, of which we've got the first term and we have got the constant difference. So therefore Tn is equal to A, which is what? 37 plus N minus 1 times what? Times D, where our D is what? -4. So let's simplify and see what are we going to have at the end of the day. So Tn is going to be 37 plus open bracket -4 times N. We have to distribute this -4 expands the other bracket. So it's -4 times N, which is -4N. -4 times -1, which is what? A +4. Then expand the brackets, that will be 37. You're expanding by the positive, so the positive, guys, are affecting this bracket is just going to remain as it is. So that's -4N plus what? Plus 4. Then we can collect our like terms from there, as we can see that we have got, right, let me just even write it here. As we can see that there is 37 and what? And 4. So you can say Tn is equal to this -4n. Then we add 37 plus 4. That was going to give us what? That was going to give us 41, just like the previous case. As we can see, we are obtaining the same Tn just like the previous one. All right, so many ways that you can answer this type of a question. Then from there, determine the 15th term, T15 of the number pattern on 3.13. So 3.13, we just need to substitute into what we are given. 3.13 T15, N is equal to 15. So in place of N, put 15 there. So that's -4 into 15 plus 41. So that's T15. We can simplify this on our calculator, or you can simplify stage by stage. It's in your hands. -4 times 15, that's -60. Plus what? Plus 41. So that's our T15, which is going to give us what? -19 at the end of the day. All right, so that is how you can play around with these questions. 3.13, 3.14, which term in the number pattern is the first to have a negative value? Which one is the first to have a negative? They are saying our Tn will be negative at that moment. 3.14, 3.14. Be very careful there. Tn is negative. What does it mean? What does it mean if Tn is negative? Is what? Negative. What does it mean? It means we are talking about the values of Tn being less than 0. That's where we start to have negative values. -1, -2, -3, negative, and so on. When they are less than 0. So this type of equation, it's not an equation, it's an inequality. Values that are less than 0, those are the ones that are negative. So for which one? We just take our Tn as it is. This is our Tn. Now it is giving us negative values. It means -4n plus 41, as it is. For any value of any that you're going to substitute, you must get what? A negative. So to get a negative, it means it's less than 0. That is what it means. That one is less than 0. It's an inequality, not an equation. So you solve for n from the inequality. -4n is less than, all right, take the minus, the 41, the other side is going to be what? -41, or just subtract that one. 0 minus 41, that's -41. We can divide by what? By -4. All right, by -4, both sides of our equation. Remember, the moment you divide by a negative, the inequality sign reverses, it changes. It was a less than, it's going to be what? Greater than. All right, 41 divided by 4, it was going to give us something like 10,25. So this is an inequality. Let's get to the answer now. The question was that which term, what is the n value that are we talking about to say? Remember, n is number of terms. So n is what? For a condition that we are going to have the first negative value, the first one. So we need the value that is greater than 10,5. The first whole number, remember, n is number of terms, number of terms. How many? Which term are we talking about? The number of terms. The first one, the second one, like that. So how many terms? Like the number of terms. We are counting the first, second, third. So it's 10,25. The next whole number is the one that we need, because we are talking about the one to give us the first. So what is the least possible value of any that we can have? It's a value that is greater than 10,25, being an integer. So that is what? 11. So therefore, our n must be 11. That is the condition of our question. We look for that integer, which is what? Which is greater than 2,5. So that is how these questions can be given as. So as you are given these questions, you are supposed to be very careful how to attempt those typical questions. All right. So n is equivalent to 11. Then they gave us a statement here. Let's figure out. They are saying that. All right, let's figure out what are they saying here for 2 marks. 2.15. They said Kanya claims all the terms of this pattern is uneven. Uneven. Remember, even numbers 2, 4, 6. So when it is uneven, it's a number that when you add 1, it becomes what? Uneven. 3, you add 1. 5, you add 1. 7. Those are uneven numbers. So he's saying Kanya claims that it's gonna be like that. There's that whatever that we get here is uneven. All right. Is this true or false? Support your answer. All right. So we can look into our expression to see if truly we were going to get what? Uneven terms or even terms. So guys, when you get something like a statement like this one, which is saying uneven, work with the even that we know. Work with the even one. So 3.15, work with what? The even numbers. We know that even numbers are the ones that when you multiply, it's just going to be a product of 2. So 2n gives us even numbers. Or it is 2 into n plus 1 as long there is a product of 2. 2 into n minus 3, 2 into n plus 4 as long there is a 2 outside. It's going to be even. But the moment we add a 1, it's now uneven. The moment we add a 1, it's no longer an even number. So let's look for a condition where we have got uneven, where an even number is it 2n, but there is now a 3 or a 1 that is being added. Is it 2n plus 3, 2 into n plus 3, then there's a plus 1 at the end. Once there is an odd number added after that, it is no longer what? It is no longer even. All right, so let's figure out. Our Tn is given as negative 4n plus 41. So the best way is to factorize, and we target 2. 2 makes a number to be even, so that's why we have to target what? 2. For us to factorize, we must have 2 terms at least. So let's rewrite this one to give us at least a 2 so that we can have a 2 there. Because if we factor out 2, it's going to be 40. It's going to give us a remainder of 1. There's going to be 40 there. So we must have 40 plus 1. 40 plus 1 gives us what? 41. So that we can factor out 2 from these two and see what is happening. If we factor out 2, it's going to be negative 4 divided by 2, which is negative 2n, plus 40 divided by 2, that is what? That is 20. But we are going to notice, since we factored out the first 2, there is a plus 1 which is remaining there. There is a plus 1 which is remaining. Guys, I said anything multiplied by 2, an expression, a term, whatever that is multiplied by 2 makes that term or expression be even. But the moment you add an odd number after that, you add 1, you add 5, you add 7, you add an odd number there, guys, it's no longer an even. So automatically we can see whatever value of n that you're going to put here, maybe you're going to get a 2, you're going to get a 3. But the moment you add a 1 to say 2 times 3, it's an even number. But the moment we add a 1, it's now uneven. So adding this one that we see there, is the one that is making that statement to be what? To be uneven. That's uneven that we are seeing. Even plus what? Plus odd. It's going to be what? Even plus odd is gonna give us what? Odd, which is what? Which is uneven. So therefore, Tanya, is it Tanya or Kanya there? Therefore, Kanya is what? Is true, because Kanya claimed that they are uneven. So therefore, Kanya is true. It's what? It's an odd. Therefore, Kanya is what? Is true. That claim is very, very true, because we can see that whatever that we are going to get at the end of the day is not an even. Therefore, it is what? It is uneven. Uneven there. All right. Given 3.2, with this, all right, 2 marks and 2 marks on 3.21, they gave us a number pattern there, which is given the number pattern 1, 4, 9, 16, and they said it has got Tn, which is given as n squared. Tn is equal to n squared. All right, determine the general term for each of the following. So it is not about this one, what we are given. So focus on what you are given there. How can we have your expression? Is it worked from that n squared? What is that we can do? The first term is 1. The first term, T1 is 2. T2 is 3, is 5. T3 is 10. So if we say n is 1, if we substitute 1 in n squared, it's going to be like this. 1 squared, which is 1. So it's not n squared. But now, what happened to get a 2? Because we can see that we are getting a 2 there. So what happened? We added a 1. 1 plus 1, which is what? Which is 2. The same thing when we have got the second one, when n is 2, in place of n, we put a 2. It's going to be 2 squared, which is 4. But there is a 5. So what happened? We added a 1 there to obtain what? A 5. So as we can see, on each and every part, we are adding a 1, we are adding a 1. Where are we adding a 1? On a number that is being squared, meaning to say on what? On n squared. So here, Tn is equal to n squared plus what? Plus 1. Once you obtain n squared, you must add 1 on that one. All right. What about the second one? The first one, here it is like T1, but our T1 is like 0 there. Where we are starting from, where we are starting. So it is like we do not have a condition like, okay, this is T0. If we want to say that's 0 there. This is T1. This is... So it's going to depend with the way that you want. But we cannot say this is T0. We have to say this is what? This is T1. So if we say our T1 is equal to 0, guys, let's put the 0 there and see what happened, because we are getting a 0 there. In place of n, when n was 1, you substitute there in place of n squared. 1 squared. 1 squared is 1. But the answer is 0. What happened? Did we add 1 or we subtracted 1? We subtracted 1. So 1 minus 1, that's a 0. Okay, let's figure out the second one. T2, n squared, that's 2 squared, which is going to be 4. But there is a 1 there. So it's going to be 4 minus 1 to get a 1. 4 minus 3, which is going to give us a 1. So this one is not going to give us exactly what we want, because that is going to be minus 1. Like we said, is 2, right? 1, 2. So it's going to be 4 minus 3 to give us what we're given there, the one that we see. It's going to be minus 3. For a 3, it's going to be 3 squared, which is 9. But that 3 squared, which is 9, is not giving us what we are given there. It is giving us a 4. So what we have, subtract a 5. So this one, it is a different situation of treating it from n squared. It is not like that. We cannot treat direct on n squared. But where can we treat it? Let's say from that n, we subtract 1 direct. We subtract from that n. Remember, it's t, n is equal to n squared. But let's say we subtract it direct to say on that n squared, the first term, the first is 1. T1, n is 1. To get a 0, we can say 1 minus 1 squared. 1 minus 1, that's what? That's a 0. So we've got what? 0 squared, which is 0 there. Okay, let's move when n is 2. In place of n, all right, we're going to have this time 2 minus 1 squared. 2 minus 1 is 1. 1 squared is what? Is 1. Exactly what we have here. For n is equal to 3, the third one, we do the same. 3, it's going to be 3 squared, all right? So here, guys, here, guys, let me see. Said 2 minus 1, which is 1 squared, all right? Then when it is 3, 3 minus 1 squared. 3 minus 1, that's 2 squared, and 2 squared is 4. So as we can see, guys, for each and every value of any that we have here, we're going to subtract 1, but everything being what? Being squared. So this is equivalent to n minus 1 squared. It's a type of a question where you just need to study the first one, then you figure out how you play around with the second one. Yes, there are proper ways. Those proper ways of doing this one, they are explained in our grade 11 mathematics. So if we are to explain it now, it's gonna be something else. But if you have time, you can visit working with the introduction of your grade 11 mathematics, where they are what we refer to as quadratic number, where the number pattern that will be given is going to give us a quadratic. Those are the ones that are in this format. But in this type of a question, it was just like analyzing. You just have to analyze what you're given, then you can figure out how to play around with that question. So we're gonna see that one, guys, later on. Very soon we'll be in grade 11, so do not worry about that. Just know your basics. They're gonna help you in your grade 11. Again, question number 4, you are given that 4.1, that Jenny buys a bicycle which costs 12,000. On hire purchase, it is what? 12,000. She is charged a simple interest of 12% over 6 years. 4.11, calculate the total amount that she will pay for the bicycle. The total amount, the accumulated amount over the period of 6 years. Simple interest. Remember, simple interest amount is equal to P into 1 plus IN. So in that case, there is no balance that you are saying she paid a certain deposit or what. So you work it from the simple from the one that is on higher purchase price, because we do not have that deposit. So our principal is what? 12,000. So that's going to be 12,000. All right, into 1 plus the interest rate as a decimal 12%, i.e. is equal to 12 over 100, which is going to give us 0.12. So that's 0.12 times the number of years. N is equal to what? Over 6 years. So that's it. You can simplify what is inside of the bracket first, or you can just use your calculator at once. So inside the bracket, we've got 1 plus 0.12 times 6, which is going to give us 1.72. So that's 1.72 times 100 and all right, times 12,000. The way that I'm writing now is like 120. This is 12,000. So if we were to multiply these two, 12,000, that was going to give us 20,640. 20,640 at the end of the day. So this is the money to be paid, all in all, at the end of the period of 6 years if it is on hire purchase. All right, how much interest will she pay over this period? So the interest now, remember, she was supposed to pay 12,000. Now she's paying 20,000. So the interest is that increase that is supposed to be paid at the end of the day. So our interest, they are not talking about the interest rate, the one that is added from what she's supposed to pay 12,000. She has to pay 20,000. So it's accumulated minus the principal. That is 20,640 minus 12,000, the one that we started with. It was what? 12,000. So 20,640 minus 12,000. This was going to give us 8,640. All right. So that's 8,640. So that was it on 4.12. Then 4.13, calculate Jenny's monthly installment. Monthly, she is supposed to pay at the end 20,640 monthly. How much is she gonna pay? 4.13. So monthly, from that 20,000 that she's supposed to pay. This one is just an increased amount, but in total, all in all, she's supposed to pay 20,640. So 20,640 over what? How many months is she supposed to pay? Because it's monthly, over a period of 6 years. How many months? 6 times 12. The number of what? The number of months. So 6 times 12, that was going to give us what? 72 months. So in all the number of months is what? 72. So divide 20,000 divided by 72, that was going to be 286,666 and so on and so on. So it's going to be 0.67 to 2 decimal places. All right, so just like that, hire purchase. This one, she did not pay a certain deposit. If she paid a deposit, you subtract the deposit. All right, you have to remove the deposit first. Then you use the formula that we used here, as this one will be the balance from that deposit. You'll be working with what? With the balance. But there, it is not the balance because she never paid any deposit. It is exactly that hire purchase value that was there. All right. Then on this question, which is on question 4.2, we are given that Kenny invests a certain amount of money at 7.2% per annum. Compound interest amount is equal to P into 1 plus I to the exponent of N, or compound interest, where we are given that after how many years would the amount have doubled? The amount that was invested, all right? Kenny invested P, principal. After how many years is that amount doubled? 2 times P. So our amount is what? 2P. That is what it means. So we can simply substitute, guys. What is the number of years? We do not know. The interest being 7.2% per annum. So divide by 100, that's 0.072. Substitute into this. Our amount has doubled from the 2p from the p. It's now 2p. So 2p is equal. The principal is what you started with. Initially, you started with that p. So it is equal to p into what? 1 plus I to the exponent of the number of years. How many years? How many years? What is the value of n? You are to calculate the value of n. That's an equation that you have formed. P and P, they are common. You can divide these. All right. So we're going to be left with 2 is equal to. All right, guys, I did not substitute something here. The I there, the I there. We have got this one, isn't it? 0,072. That's 0,072, like that. All right. So you can even simplify what is inside the bracket 1 plus 0,072. You add this one plus this one. That's 1,072 to the exponent of what? Of n. Remember your logarithms, how to solve for n. There you must go back to your logarithms. A to the exponent of c, in that manner, if you are to write it maybe as a to the exponent of b, or let's just write it in log form, whatever that you want. We can have it in log form like this. All right, this is exponent form. A to the exponent of b, which is equal to c, follows that it is the logarithm of what? It is the logarithm of c that we are given in the base of a, which is equal to what? Which is b. So meaning to say a to the exponent of b is equal to c. All right, whatever way that you're given or that you understand, a, the number which is our base, this one, is going to be on the log base. So what it is representing our a, in that case, this is our a to the exponent of what? Of b must be equal to c. So that is it. So it simply means in log form, it is the logarithm of what? C. What is our c there? What is our c? C is the answer that we're given there, the answer that we're having there. So it's log 2. In the base of A is not changing. All right. 1,072 is equal to B. What is our B? Our B is representing N. So we can see that we have got our N there, which is log 2 in that base. So guys, you can use any way that you understand conversion from exponential form to what? To log form can help us to find that N. Since we have got our calculator in the base of what? 1,02. Press this log. That's in the base of 1,072. In the bracket, we put 2 there. So that was going to be 9,969 and so on, which is 9,7. But we are talking about any being the number of years. How many years? So any approximates. This one, it is going to be an approximation to the nearest whole number. It is going to be what? It's going to be 10. So meaning to say it's going to approximate to 10 years to double the amount that that person started with. That investment is going to take approximately 10 years to what? To double. That is what it simply means. That is what it simply means on 4.2. That was the type of a question. Let's see. 4.3, we are given this table as it shows the exchange rate of the British pound and the South African rands, as well as the US dollar and the South African rand there on a what? On a certain day. All right. So there are two things: the British pound, South African rand, and what? The US dollar. All right. So the question on 4.31, calculate the exchange rate between the British pound and the US dollar on that day. So there we are given the pound to the rand, the dollar to the what? To the rand. So guys, we can simply work this one straightforward as they want British pound to what? To the US dollar. you simply have to divide as it is, because these ones, they are all in what? In rands. So it simply means each of the British pound is gonna be, as we have pound over dollar, but in terms of what? The rands that we are given. So it's what? 23,04 for the British pound that was given in terms of rands, and 17,32, which was representing what? The US dollar in that case. So that is the idea. You just divide those as they are, the British pound to the US dollar, in terms of the one that, as long as it is the same currency that you're dealing with there, as long as it is the same thing, you can work with that and divide. So it's gonna be 1 pound equivalent to the US dollar. How many? That's gonna be what? 23.04 divided by this. Let's see. 23.04 divide by 17.32. So that is gonna be 1.33 to 2 decimal places. So it's already converted to the dollar. Remember, it's pound to the dollar, pound to the dollar, pound to the dollar. So that's 1,33 that we are given there. All right. Then on the other side, we are given, or on the other part of the question, that Brent crude oil costs 74.59 a barrel. Calculate the cost in rand of importing a barrel of Brent crude oil. The cost in rands. Related to what? To the dollar, guys. Already there is a relationship between the rands and what? The dollar there. We'll use that. Each dollar is equivalent to what? 17.32 rand. So what about 79.54 rand? What about that? 74.59 rand. What is the equivalent? It's going to be more. So when it is more, guys, we're going to simply divide this one over 1 times this, or you can use that cross multiplication that we used to have, guys. So it's going to be 1 times x, which is x is equal to, you multiply these two, 17.32 times 74.59. This is a direct proportion. So you just have to multiply the two. So that is it. The total in rands, if you multiply this, it was going to be 1,291, 8,898. It was going to be 0.8988. So this 8 is going to change this 9 into a 10. It changes this into a 9. So it's going to be 0.90 to 2 decimal places. Or you can just fix your calculator to 2 decimal places, guys. You're going to get your answers direct. Let's say you fix your calculator to 2 decimal places. You know that your answers, all of them, will actually be direct as from what you are given, from what you are given from that particular section. So moving on to question number 5, we were given that the graphs of f of x. So there's f of x, which is ax squared plus q. All right, so that's our f of x, which is ax squared plus q. And also we have got the one for gx, which is given as 3 over x minus 1. For each x is greater than 0, there we are talking about all the real terms of x. So we have got a is the x-intercept of both graphs, and hence a point of intersection, which is very true. A here, that is the x-intercept in the x-axis, and an intercept for these two graphs that we are given. And B is the turning point, 0,9. Then CD, this one is a vertical line segment on the y-axis, with a C on F and D on what? On G. So that is what we are given. And from this information and the diagram, we were being asked on 5.11 to determine the range of f. So the range of f, we are determining what? The y values. which we are limited to. All right, so we are limited to the turning point. As we can see, our values will be from negative up to what? Up to 9. The turning point, remember the y value 0, 9. That's x, y, the y is equal to 9. So we can have any value, negative 1, negative 2, negative 3, negative 4. But as we are going up, we cannot exceed the 9. So our y values, they will be less than or equal to 9. All right, where y will be an real term again, just like the previous case. Or we can take our y from negative infinity up to what? Up to 9. All right, we can even represent that way. So that is the range. We are comparing the y values. Then the domain of G, we're talking about the X values, of which you are already given, guys, from our G, which is representing our hyperbola. We are given that our X values, they are greater than what? Greater than 0. So already the domain, we are given X is greater than what? 0 there. Write down the equation of the horizontal asymptote of G. The horizontal asymptote, horizontal, guys, we talk about a line like this. So these are the lines which are in the form of y is equal, just like the x-axis, y is equal to 0, y is equal to 9, y is equal to whatever that you have. That's horizontal. It's in the form of y is equal to. All right, y is equal to what? That is the asymptote. So already on gx, y is equal to, this is our part of the asymptote. Remember, when you're given gx is equal to a over x plus b plus c. This c is an asymptote for the y, which is y is equal to c. All right, for the b, we take this x plus b is equal to 0, which is for x. For x there, if it is vertically, that is, where am I writing c, guys? Here we need what? Minus 1. The y is equal to minus 1. All right, so I was saying for x, if it was for a vertical, x here is equal to 0. There is nothing that we can compare like x plus b. It is just x there. So x will be equal to what? X will be equal to 0. So that is the case. X will be equal to what? X will be equal to 0. But we are not asked about this one. We are asked about the horizontal lines. These are the lines of y is equal to something. Y is equal to. So that's where we have got here. Y is equal to negative 1. This is the part of the asymptote. Okay, so let's move on and see on the other part of our question, which is, okay, 5.14. Determine or write down the values of x for which f is decreasing. F, all right, our f in this case is the quadratic. This one, this is our f. Where is it decreasing? So as we can see from here, these values will be increasing, going up, going up, going up, going up to the 9. Then now they start to decrease. So they start to decrease at this point where x will be greater than 0. At x is equal to 0, that's the turning point. There is no movement. All right. But once we start to move from these values, 1, 2, 3, and so on, these values, they are going to be going down. They will be decreasing. That is y is equal to 8, 7, 6, 5, 8, 0, minus 1, and so on. They will be decreasing. So that is right, 5 point what? 5.14. For the values of x, which are greater than what? Which are greater than 0. Thus, for all these values being real terms, the y values of f will be what? Will be decreasing. That is going down. So when you're given a function like this, at the turning point, going up, that's an increase. Then this one, it's a decrease, all right? When you're given in this format, this is what it means. You are going down, that's a decrease. To the turning point, then you start to go up, which is a positive, all right? So you just have to know the type of, the shape, not the type, but actually the shape. You can actually work it from there. Then determine the values of A and Q, where do we have A and Q? A and Q, they are found on what? On f of x. So we can actually work on that one. That's 5 point what? 5.2. All right, let's just try to do it here. 5.2, we need to find the value of A and what? And Q. So remember, guys, I talked about these typical functions to say, when you are given f of x is equal to ax squared plus q, direct added to ax squared, this q that we are seeing there, it is the y-intercept, which is our turning point. The y-intercept where x is equal to 0. When x is equal to 0, y is equal to what? Y is equal to 9. So it means our f of x is equal to ax squared plus q, which is 9. The y-intercept there is what? It's positive 9. So we have got the value of q already, the y-intercept. What about a? To find a, we can substitute any point which is found on our f of x. Any point which is on what? Which is on f of x. Any point. So which point can we use that is on f of x? We cannot use the 0, 9, this turning point, because is the one that we have 9 there. We look for another one. We can use the point A. As A is the x-intercept, we can determine that value because it is the x-intercept for both functions. So at A, find the x value there. That's at A. The x value is going to be what? We can use gx because it is a complete equation. X at A, we are talking about the x-intercept where y is equal to what? Y is equal to 0. So in place of y, put a 0 there from what? From gx. That's 0 is equal to 3 over x minus 1. Solve for x. So the minus 1 to the other side is going to be a plus. That's 1 is equal to 3 over x. So to find x, simply cross multiply. That is 1 times x is equal to 1 times 3, which is 3. So the value of x at the x-intercept at the point A there, where we have got our A here, the value of x is 3. So as a point, that's 3, 0. Remember, y is equal to 0 in the x-axis. So we can use the point A, which is 3, 0 there, to find the value of x. To find the value of A. Remember, we need the value of what? The value of A this time. We can substitute this point because it gives us the x and the y value. Y is what? In place of f of x, y is 9. That's 9 is equal to A times our x. Our x is what? 3. So that's 3 squared plus what? Plus 9. All right, so let us solve for A. In that manner, what are we going to have at the end of the day? That is 3 squared. All right, so this one also is going to cancel. All right. 3. All right, is there anything that I missed here? Ax squared. All right, plus q. That is 9 there, and we have got another 9 in that case. All right. This is 0. Where am I getting this 9, guys? This is y there. 0 there. I'm like, what is happening now? All right. That's the y value there, which is what? Which is 0 there. Let's correct that one. 3 is 0 there. The y value there. That's a 0 there. I was like, where is this calculation going when it is like this? Anyways, now we can actually determine the exact value. Take this to the other side. That's going to be a negative 9 equal to 3 squared, which is 9 times a. So that's 9a. Divide by 9, divide by 9. So this is going to cancel. A is equal to what? Negative 1. All right, so these are the values, guys. A is negative 1. Q is equal to what? Q is equal to 9. So meaning to say, from this, our f of x here, it simply means it can be written as a. Remember, we said a is what? Negative 1. So that's negative x squared, negative 1x squared. So it's negative x squared plus q. our q, which is what? Which is 9, like that. That is what it means. But the question is not about writing the equation. It is to determine, just write q is 9, a is what? A is -1, all right? So that is how we can easily attempt these typical questions. 5.3, write down the equation of the line of symmetry of G which has a positive gradient. Remember, G is our hyperbola, this one. So they must specify the equation of the line of symmetry, say which one, because remember, we are supposed to have two. If it was gonna be the one with a positive, there's another one with what? A negative. When they are given two functions, that is our normal understanding. When you are given something like this, you've got a hyperbola, this one and this one. This one has got negative, this one has got positive. So in our case, the one that we are going to work with is the one with the positive gradient. So we do not know, is it going to be like this? Is it going to be like this? Is it going to be like this? But what we know from that consideration is that it must have what? A positive gradient. So when it has a positive gradient, how do we calculate its equation, guys? All right. So, all right. How did I end up with this one here? Let me remove this and this. So this is what I want you to know, guys. When you're given this condition, remember, this is y is equal to -1 here. So the equation can be given as y is equal to x plus c for a positive gradient. When it has a negative gradient, y is equal to minus x plus c. It is always x minus x. There is no other number that we must have 2 or minus. It's always 1 or -1. So when it has got a positive gradient, we're going to use the first one, which is what? A positive 1. So what we just need is to find the value of c, which we can determine from the asymptotes, because the line that we are going to have is going to pass through the asymptotes. Remember our asymptotes, guys, we said there is x which is equal to 0 from this one. As we are just given a single term there, it simply means our x is equal to 0. So our asymptote is x is equal to 0, which is our y-axis, this one, and the and this one, y is equal to -1. So those are the ones. X is equal to 0 and -1. So at the intersection of the asymptotes, it's a point where this line is going to pass. It is going to pass through x, which is 0, y, which is -1. So you can take advantage of that. Substitute in place of y there, -1 is equal to our x. Our x is 0 plus c. So -1 is equal to c. That's it. So that's going to be y is equal to x as it was before plus, so we're going to add -1, plus and minus, that's minus. So that's our equation. All right. So that was actually a straightforward question that we were given there. Just have to revise as much questions as possible. 5.4, if hx is equal to minus f of x minus 3, determine the coordinates of the turning point of h. We are given there to determine the coordinates of the turning point if we are given a certain function of hx. So first of all, analyze what you're given, guys. This is 5.4. There are so many ways. They said hx, which is a new function. Hx is a new function. H of x is equal to what? Minus f of x minus 3. So we want to calculate the turning point of hx, which is our new function. We can work it from the original f of x. Remember our f of x, this original function, we have got its turning point from f of x. It follows that our turning point there is what? As given there, b is our turning point, 0 what? 0, 9. So this is what you do. You analyze the transformation which happened. So you're going to analyze the transformation which happened here from f of x to give us the hx, what happened? They are saying minus f of x minus f of x means we are transforming the function, the y values are being affected by a negative one, which is a reflection in the x-axis. Remember your reflection in the x-axis from your grade 9 transformation. So the y value, f of x, it is the y value that is being affected there. So it means on our turning point on hx, our turning point, this is what is going to happen. The x value is not affected. Minus f of x, it is the y there. Reflection in the x-axis, meaning to say y values are affected. If you had a condition where it was x, y like this, minus f of x, it simply means it's x, then the y is multiplied by a negative like this. From y, it's now minus y. So x is not affected, this one. It remains as it is. The y value is affected. How is it affected? Minus 9. Minus 9. So we're going to affect it by a negative. So that's negative 9. After that, we subtracted a 3 from the same y value. We had to subtract a 3 from the same y value. So that's our new turning point. So meaning to say our turning point is going to be what? X, which is a 0 there. Then we simplify minus 9 minus 3. Guys, if we expand this bracket, it's just going to be minus 9 minus 3. Minus 9 minus 3 is what? Minus 12. So that's our new turning point, which is 0 minus 12. You analyze the transformation the way that it is given there. Direct. Or maybe you do not understand this, therefore find hx, the new function, because f of x is there. Remember, we substituted the a, which is minus 1, and the q there. So find that hx the way they gave us there, minus f of x. So that's another way. Minus f of x, this is f of x, as it is, minus x squared plus what? Plus 9. After that, subtract 3. After that, subtract 3. So this is what we have. hx is going to be given negative, negative, that's positive, x squared. Negative times 9, negative 9. Then we're going to subtract these 3. So that's it. hx, our new function, is given as x squared minus 9 minus 3, which is minus 12. As we do understand any function of this nature, the turning point will be on a condition where we are dealing with this part of the minus 12, the constant. Just like what we had, guys, here when we are given minus x squared plus 9. The 9 there, that was part of our turning point, 0 what? 0, 9. So what about this one? What will be our turning point? Our turning point when x is 0, we're going to remain with what? Minus 12. So that's 0 minus 12, just like the previous one. So your functions from your grade 10, guys, they are just direct functions that you need to know the basics. If you know your basics, you're not going to have problems. So that was it. Then 5.5, calculate the length of CD if the y coordinate of point D is 2. The y value at point D is 2. All right, what an interesting question. Let's see. Let's see what we are given there. The y coordinate at D. This is where we have got our D here. Remember, D lies on what? D lies on G, on this function of G. So on D, they are saying the y coordinate, the y value is what? Is 2. So if the y value here is 2, take it straight like this. It simply means there is a 2 there. The y value is 2. We are told about the y value there. So when you're asked to find the distance between C and D, the distance between C and D. This one, this distance. It's a vertical line, remember. So it follows that the distance that we are given are simply the units between C and D. How many units between C and D? Which is the Y value at C minus the Y value at D. So you can say the Y value at C minus the Y value at what? At D. Y1 minus Y2 if you want it that way. What is the Y value? We need the Y values. Vertical lines, we work with the Y values. So we have got the Y value at D. This one we have got at D, we have got this Y value, which is what? Which is 2. We are told that one. But we do not have now the Y value at C. What can we do? Remember, C lies on what? C lies on F. So we cannot use the Y value at D and say it is the same Y value at C. No, it's not the same. What is the same when it is a vertical line like this? It is the X values. According to this vertical line, we have got the same value of X here. It is the same. So we are going to take advantage of what? We are going to take advantage of this function G, because the Y that we are given at D, where Y is equal to 2, it is on what? It is on GX. So we take advantage of that GX. We find X from there to say when GX is equal to 3 over X minus 1. But at that moment at D, at the condition of our vertical line at D, Y is what? Is 2. So you take advantage of that. Y is 2. So what is the value of X? You solve your X there. Just like that. It lies on GX, so you use GX. If it was on f of x, you're going to work with f of x so that you now find the GX. So let's solve. Minus 1 to the other side, it was going to be positive 1. 2 plus 1, that's 3, which is equal to 3 over x. So to solve for x, 3 is same as what? 3 over 1. So I can simply cross multiply 3 times x, which is 3x, is equal to 1 times 3, which is 3. Divide by 3, so x is equal to what? 1. So the x value there is what? Is 1. Remember what I was saying. It is the same value of x since it is a vertical line. The same value of x, what does it mean? It means at D, x is equal to 1, y is 2. Remember we said y is 2 there. What about at C? Because we know that x is 1, x is not going to change. So at C there, we know that x is 1. What about the value of y? We do not know. So that is where now we can use our original f of x, because C lies on what? On f of x. So that is what we need now. So we need to find what? The y value at what? At C. So now let us find the y value at what? At C. Where C lies on what? It lies on f of x. So we're going to use f of x. Remember, f of x, it states that it is equal to what? From what we substitute the a and q, we ended up with minus x squared plus 9. So from that minus x squared plus 9, let us substitute, because we now know one thing for certain, for sure, that where x is, where C is here, where C is situated, x there is what? Is 1. That is one thing for sure that is not going to change. So where x is equal to 1, what is the value of y? Y is equal to minus, in place of x, 1 squared plus 9. So y is going to be equal to minus 1 squared, that is 1, plus 9. So minus 1 plus 9, which is what? Which is 8. So that is the y value at what? At C. The y value at C is what? Is 8. So there is 8 here. So therefore, we're going to have the length of CD. The y value at C, which is 8, minus the y value at D. Originally, we were given that, which is 2. So 8 minus 2, that's what? 6. So it's going to be 6 units. that is going to be 6 units, the distance in between those 2 points. So that was it. It was an interesting question, a lot of things to apply, which we can just apply direct and have our answer them. All right, question 6. Consider the exponential function here, f of x is equal to this, 6.1. Calculate 6.11, the x-intercept of f. So x-intercept y is equal to 0, guys. So substitute 0 there. That's it. So 0 is equal to 2 times 2 to the exponent of minus x minus 4. Take the minus 4 to the other side. It's going to be positive there. So 4 is equal to 2 times 2 to the exponent of minus x. All right. That's divide by 2 here, since we've got a product. So 2 is equal to 2 to the exponent of minus x, where we understand any number when it is written, it is same as what? To the exponent of 1. We're back to your exponential equation. Same basis, you equate the exponents. 1 is equal to minus x. So divide by -1 by -1 to find what? X. So that's -1. So our x-intercept is -1, 0 there, where x is -1, y is equal to 0. Then the y-intercept, just like the previous case, y-intercept here, we do understand for the y-intercept, x is equal to 0. So this time in place of x, we put a 0 this time in place of x here. So that was going to be y is equal to 2 times 2 to the exponent of 0 is 1 minus 4. So that's going to be 2 minus 4, which is what? Minus 2. So that's the y-intercept, 0 minus 2. Okay, then what is it? What is it? What is it again? Then sketch this graph. So we need the asymptote in order for us to sketch this graph. So what is our asymptote? The first one is going to be here, the y value at what? -4. So that is going to be at -4, the y value at -4. That's an asymptote for an exponential function. The x is not affected. So the shape, that's a negative. If it is, let's say we're given an exponential function, when it is a positive, y is equal to whatever, to the e to the exponent of x, a to the exponent of x, positive is like this. But when it is negative, it is like this. So as we are dealing with a negative, we're going to expect a shape of that nature. Where an asymptote is, then the shape is like this. That's for a negative exponent of x there. All right, so let us see what we have. Do we have any part? I'm just gonna sketch it here. All right, let me see. All right, I've got a graph here. So lucky enough, I've got a graph here. So this is our x. These are the y values. So let's start with the asymptote. We said our asymptote y is what? -4 there. That's our asymptote, remember? Asymptote. So y is -4. So y is -4. This is where we have got our -4 for the y values. All right. Then let's save the x-intercept -1, x-intercept -1, exactly in the x-axis at -1, exactly in the x-axis. So that's -1. Y-intercept -2, -2 like this. And remember the shape. So this is our shape for a negative exponent. So our shape was gonna be like this. Right, we join these two like this. So it tends to reach this -4, but it's not gonna cross -4. All right, so that is it. That is it. Y is equal to 2 times 2 to the exponent of -x -4 as it was given, or just f of x. All right, just f of x is equal to f of x is equal to this. All right, so let me just finish, guys. It's just like it's raining right now, so I'm just gonna quickly finish up so that we can see for revisions next time. All right, describe the transformation. 6.3, describe this transformation f to h if h is given as this, all right? So let's study and see. We need to describe this. Where is our h? Where is our f? This is our f. So let's try to study and see what happened, what actually happened. It was like this. F of x is equal to 2 times 2 to the exponent of minus x minus 4. Now it is hx, which is 2 to the exponent of x plus 1. All right, what happened with minus 4? That is the first question. It is now a 0. There is nothing there. It is like just like plus 0. So what happened? It was a minus 4. To give us a 0, we added a 4. So adding a 4 on f of x to say f of x plus 4. Remember, what does it represent? F of x plus a, f of x plus b, whatever that you're going to have. It is a shift of a units going up, plus. So that is 4 units up. In our case, to get a 0, we shifted 4 units up. So there is a shift of 4 units up. So that is shift 4 units up. All right, that's the first one. What happened on the second one? To get this one, to get 2 to the exponent of x plus 1. All right, this one is fine. Let's talk about this remaining part. Let's simplify it first on f of x. On f of x, 2 times 2 to the exponent of minus x means what? This is 1. All right, this is 1, remember. So a product, you add. So it's going to be 1 plus minus x, which is what? 2 to the exponent of 1 minus x. This is the original one from our f of x. This is the original representation. But look how it is written on hx. What happened? The x that we see, it is the only one which changed. Remember, 1 is positive. Here, 1 is positive. But if we check, x, it was minus. Now it's a positive. So we multiplied direct minus x. We multiplied direct the value of x. Multiplying direct the value of x, it is this transformation minus f of minus x. F of minus x like this. This transformation means you multiplied direct the x value by what? By a negative. You multiply direct the value of x. It's a reflection in the what? In the y-axis. Remember from your grade 9 mathematics, this one. It means what? Reflection in the y-axis, all right? So there it is a reflection. So we also reflected. We also had a reflection in the what? In the y-axis. So those are the two. Those are the two transformations. You study from the original to the one that you now have to say what actually happened in order for me to get this. All right. Then later on, they wanted you to sketch gx, which is equal to 2x plus 2 on the same grid where we answered 6.2. All right. On this same grid, gx, which is equal to 2x plus what? Plus 2. So when you're given this type, it's a straight line. Remember, we're just going to need x-intercept, where y is equal to 0. So 0 is equal to 2x plus 2. Minus 2 is equal to 2x divided by 2 by 2. So x is equal to negative 1. So that's our x-intercept, negative 1 here. Let's move on to the y-intercept. The y-intercept, x will be equal to 0. So if we put 0 there, y is equal to 2. So that's our y-intercept here. So we can even join. It's enough for us to draw the straight line given the x-intercept and what? And the y-intercept. Those two, they are enough, all right? So we're just going to use these two, minus 1 and what? And 2 like that. Those two, they are enough for us to have a straight line, just like that. So this is our straight line of y is equal to 2x plus what? 2x plus 2. All right, just like that, just like that, just like that. Let's check another part of the question. For which values of x is 6.51 f of x minus gx is less than 0. So when you're given two functions on one side and there's a minus, take the other one to the other side. F of x is less than what? Gx will be positive there. So where is f of x less than gx? Where is f of x below what? Below gx. Where do we have the function f of x, this one? Where is it found below this one that we are given of what? Of our gx. Remember, this is our gx, y is equal to this. That's our gx. Where is it found below? F of x is less than gx. It is below here. From this one, it is going down. Gx is going up. For the values of x, as we are going this side, all right, gx is going up, whereas f is going down. As you can see, f of x is going down. So from this point at -1 there, from that condition, x must be greater than, at -1, they are equal. But once it moves there, 0, 1, 2, 3, as you can see, at 0 it's minus, at 1, this one is in the negative, this one is in the positive. So from there going to the positive, that function is going to be what? Is going to be below gx. F of x will be less than gx. So x is supposed to be greater than what? X is supposed to be greater than negative what? Negative 1. Yes, negative 1. So that is our condition there. X must be greater than negative 1, and x being a real term. Then 6.52, f of x by gx is less than or equal to 0. When they say this type, they are saying if you take to get a number which is less than 0, it's a negative. It means f of x can be negative, and gx can be positive, or f of x can be positive and gx can be negative. So let's check which one is giving that condition. One is positive, as we can see here. F of x is positive throughout up to here, where for these values of x, this one, gx, is in the negative. So positive times negative gives us what? A negative. From 1 going through this side, if we check on this side, gx is now positive. F of x is in the negative. So positive times negative gives us what? Negative. So all regions, this region, it gives us negative. This region, it gives us negative. Compared to what? We are comparing to -1. So meaning to say x for all x values, because remember they said what? Less than or equal to 0. At -1, they are all at 0. So the product of two numbers, 0 times 0 is what? It's 0. So meaning to say, this one, we need all x values. For any x value that you choose and substitute in those functions, if you multiply, you are going to get a negative. This one, guys, is all for all x values, for all real terms. It was for all x values when it is like this. You study the graph. We just hope, guys, time is gonna be there where we can find more explanations, more time, like ways of illustration. But this is exam, guys. Remember, exam, we do not go into deeper. Just want you guys to know the basics. All right. Question 7.1. In a random experiment, A and B are two different events. Probability of A is what? Probability of A is 0.4. Probability of B is K. Then if the probability of A or B is 0.6 on 7.11, determine the value of K if A and B are mutually exclusive. Remember, mutually exclusive, they do not meet. There is nothing in between these two. That's the intersection. The intersection of A and B, the probability of A and B must be what? Must be equal to 0. There is nothing there. So what can we do to find the value of K? Remember, from probability of A or B, probability of A or B is equal to probability of A plus probability of B minus this one. But there is a 0 there. There's nothing that you're going to subtract. So therefore, for mutually exclusive, it follows that these two, they are equal. Where we have this one, probability of A or B is there. We are given 0.6. It is equal to what? Probability of A, we are already told or given that one in the first place, 0.4, plus probability of of B, which is K. So we can find the value of K. Take the 0.4 to the other side. That's 0.6 minus 0.4, which was going to give us what? 0.2. So 0.2 is equal to K. All right. So that is the condition that you just needed. All right. Then on another condition, they are saying the value of K for which A and B are complementary events. If two events are complementary, what does it mean? Those are the ones that the probability of what is in A plus what is in B must give us a 1. If there are two subsets, if it is one subset, probability of A plus its complement must give us a 1. So that is the complementary condition. Complementary, remember, you get a 1. So that one of A is there. That's 0.4. What about of B? That's our K. So it must give us what? 1. So that's we can solve for K to the other side. That's subtract 0.4, subtract 0.4. So our K is going to be 1 minus 0.4, which is what? 0.6. All right. So that is what we had for complementary events. 7.2. For two events V and W, we are given that which are not mutually exclusive. They are not. So if they are not mutually exclusive, like here, mutually here, we talked about mutually exclusive separate. So if they are not separate, it means there is what? There is an intersection. They are inclusive. So these ones, they are inclusive, all right? Mutually inclusive. Given this information, probability of V, probability of W, V or this, and V and this is X. Represent this on a Venn diagram. All right, so we can represent this on a Venn diagram, guys. All right, so we're just going to have this here, 7.21. There are two subsets, and there's an intersection. V and W means there's an intersection there. So that's our sample space. Remember, the probability of the sample space is 1. So we've got V, and this is W. The intersection of V and W is there, is given as X, as unknown. So this is X. Then V is 0.5. Everything here, the whole set of V. But there's one X there, which is between V and W, which is probability of both. So we must subtract that X. 0.35 minus X. All right. W is given, so we must subtract 0.55 minus X. All right. Then they gave us the probability of V or W. When you combine these two, when you combine them like this, that's what you're given there. 0.80. So what does it mean? We can use the probability of the sample space, which is 1, subtract V or W to get what is remaining in the outer space, this one. Since we are given V or W, we can find the outer part, where the outer part represents V or W complement what is not V or W. What is not V or W at the end? So it's going to be 1 minus 0.8 of what is in V or W. We get rid of V or W. So that was going to be 0.2. So it's the remaining one outside there. All right. So it was important for you to know this one, because most of you guys were going to leave that one unattempted, just like that. So 7.21, that's our Venn diagram. And determine the value of X from there. We can simply form an equation, as we have got each and every part. The probability of the sample space always equal to 1. So take this one, 0.35 minus X. You add to X, you add to 0.55 minus x, you add to the 0.2, you must obtain the probability of the whole sample space, which is 1. So that was it. All right, minus x plus x cancels. You're going to remain with minus x there. You add the numbers together, 0.35 plus 0.55 plus 0.2. You are going to get, all right, if we add this, you're going to get something like 1.1. 1, which is equal to 1. So let's take the 1, to the other side, or simply subtract 1, subtract 1, so that's negative x is equal to negative 0, divide by negative 1 by negative 1. This was going to cancel, and we have got our x, which is what? Which is 0, all right? So that's it. That's our x there. So our x is 0, then they want us to determine the probabilities. So for you to determine these probabilities, it is best for you to substitute the x that you calculated, guys. So just forget about this. Let's go back to the x that we had calculated so that we can properly answer this. This is x. Remember, our x is what? Our x is 0, so we're going to put 0, there. This is 0, 0.55 minus 0, 0, 0, like this. It's going to be 0.45. So this is 0.45. We substitute everything. So that's 0.45. 0.35 minus 0, that's going to be 0.25. Is that so? So this one is going to be 0.25. So by doing this, it's going to be easier than for us to say, let's say we've got that, then we start now to substitute the x later on. No, guys. So when you're given this, we have substituted everywhere where we had the x value. So we had substituted. Now let us determine 7.23. The probability not v or w, like this, not v or w. So not v simply means v complement, all right, or simply means union w, like this. So what is not in v, we combine it to what is in w. All right, let's just figure it out like this. This is our v, this is our w. What is not in v? This is it. What is not in v outside of what? Outside of v, like this. What is not in what? What is not in v outside of v? All right. This is v complement. What is not in v outside of v? This is what it means. Outside of v. But what is outside of v, what we indicated here? They are saying now union, combine it with w. W is this set. So we combine it with w. This one. We combine, or that is union. Everything must be taken. So if we are to take everything, we take every part which is shaded. So the part that is shaded, we can see it is the outer part, this part of v of w only, and this part of 0, it is only this part that is not shaded, this one that is remaining, the 0.25. It is only this part that is not part of our answer. So our answer, guys, was going to be the sum of what we see here, the 0, the 0.45, and the 0.2 outside. So that was it. You're going to get your probability of 0.75. Or you can say, since it is the part that we need here, since it is this whole section that we need, and it is the v only, this one that we do not need, simply subtract it from 1. Since the probability of sample space is 1, so it's 1 minus the probability of what? V only, what is only found in what? In v. And v only is what? 0.25. So 1 minus 0.25, that was going to be 0.75. As we can see, that was another way of obtaining this answer. So many ways. All right, let's move on to another one. That is how you answer these questions. You just have to figure out, guys. There they are saying this time it's V 7.24. The probability of V, and take note when there's an and, it's an intersection, and not what? Not W, and intersection. All right, not W simply means W complement. So let's figure out, we can even redo the same way that we did there to say these are two sets, V and W. Let's figure out not W. What does it mean? Not W, it's outside of W. This one. This is our not W. Outside of W, like this. That's not W. But they're saying what is not in W? Intersection now. That is end, intersection. V, intersection V. This is our V, this one. V, this is our V, this one. This is our V. The whole of this part that I'm shading is V. So when we talk about an intersection, we are talking about elements which are found in both V and not in what? In W. Not in W. So we need the part which is shaded both. Which section is shaded both? Where we see the green and the black. The part which is shaded both, we can see, we can trace it properly here. We can see it is this section here. The part which is shaded both, this one, which represents what? Which represents V only. It is the part of V only that we need on our answer. That is the indication of what you see there on the diagram. That is where it is on your diagram. So it is the part of what? V only. It is the probability of V only that we are talking about. And what is V only? 0.25. Just like that. Just like that from the diagram, it's there. It is there, that probability. So these diagrams, I just wish, guys, we're gonna find time talk about these Venn diagrams in advance. There are so many things that you can actually understand and use to answer your questions as you are dealing with the Venn diagrams. We just hope with time gonna be able to do that. But for now, that is it, guys. Let us do revise as many questions as we can as we are preparing ourselves for the exams that is ahead of time. But for now, that is it, guys. Till we meet again.